First, let's review the experiment performed by Ørsted. He discovered the connection between the magnetism and electricity. A magnetic needle is deflected when placing it nearby a wire carrying a current. This shows us that the magnetic field is actually produced in space around the current. In other words, the source of the magnetic field is the current. But what about a magnetic field produced by a current? Beer and Zavart obtained a mathematical expression which gives the magnetic field at some point in space due to a current. Now let's talk about the details. Please look at this figure. Suppose there is a segment of a wire with an arbitrary shape carrying a current I. We divide the segment into an infinity number of length elements ds. Each length element vector has a length of ds, and we define the direction of the length element as the direction of the current at this point. We then could determine the magnetic field dB at some point P created by the differential current element IDS based on the following experimental observations. First, dB is perpendicular to both ds and to the unit vector r roof, directed from ds toward P. According to this observation, the direction of dB could be determined by the right-hand rule. Secondly, the magnitude of dB falls off as 1 of r squared, where r is the distance from ds to P. Third, the magnitude of dB is proportional to the current I and to the magnitude ds of the length element. Fourth, the magnitude of dB is proportional to sine theta, where theta is the angle between ds and r roof. We could summarize these observations and arrive at the mathematical expression, which is known as Beer-Zavart law, as shown here, where μ0 is a constant called the permeability of free space. Notice that the expression in form is remarkably similar to the expression for the electric field due to a charge element. Obviously, the magnitudes of both fields fall off as 1 of r squared. R is the distance from the source creating the field. However, the direction of the two fields are quite different. The electric field created by a point charge is radial, but the magnetic field created by a current element is perpendicular to both the length element ds and the unit vector r roof. Another difference is related to the source of the field. We know an electric field is established by electric charges. The electric charge can be isolated, such as an electron and a proton. On the other hand, the Beer-Zavart law gives the magnetic field of a current element at some point, but such a current element cannot be isolated. A current element must be a part of a current distribution because we need a loop for the charges to move. Therefore, the Beer-Zavart law is only the first step to calculate a magnetic field. It must be followed by integration of the current distribution as expressed by this one. Please note, the integral is a vector integral. We must be very careful about the direction. Well, in the next lecture, I will give you some examples to show how to calculate the magnetic field by applying the Beer-Zavart law.